Maybe you've seen something rolling around on the internet about how the heart of a blue whale can weigh as much as a car. Like anything else you see online, on Facebook or Twitter, in the news, or maybe something someone tells you, you should ask yourself, is this true? Scientists report that the largest blue whale heart weighs about 600 kilograms. One of the lightest cars is the 1960s Volkswagen, which weighs in at 1,600 pounds. This car didn't have much going on its interior. Look how small it is. It didn't have an AC or a decent suspension. It was missing a lot of the things that we consider essential in our cars today. So which is bigger, a 600-kilogram blue whale heart or a 1,600-pound Volkswagen? Obviously 1,600 is a bigger number than 600. But is a pound bigger than a kilogram? We can't actually compare these two things directly. They're from two different systems. The pound is from the imperial, or customary or U.S. system, while the kilogram is part of the metric system, which is a system used by scientists, engineers, and actually most of the world. Turns out there's actually only 3 countries in the entire world that don't use the metric system. Those 3 countries are the U.S., Liberia, and Burma. And it's very important to realize that the metric and the imperial systems are different. When people such as scientists collaborate from different countries, if they don't compare their systems correctly, disaster can occur. In 1999, a Mars Climate Orbiter was lost in space when it exploded outside of Mars' atmosphere due to a simple conversion error when someone did not convert their pounds into newtons properly. This led to the orbiter not being able to get into the atmosphere and instead wasting $125 million when it exploded. This is incredibly embarrassing because, as it turns out, conversions are incredibly easy. When we're thinking about our whale heart versus car problem, it takes a simple search in any textbook or online to see that 1 pound equals 0.454 kilograms. This answers our question of whether or not a pound is bigger than a kilogram. Clearly, it isn't. And in fact, the kilogram is bigger than the pound. So when we look at our problem, the 600-kilogram whale heart versus the 1,600-pound Volkswagen, we need to convert one of these two numbers into the system of the other. We know that 1 pound equals 0.454 kilograms, and through how math works, we can divide both sides by 1 pound, which then means we can cross out the 1 pound over 1 pound, because we know that equals 1, and this is the basis for all conversions. So what we're going to do is convert the 1,600 pounds into kilograms, because we're scientists, or at least in the science class, and we're always going to try to convert everything to the metric system. This now becomes a game of units, which means we want to make sure, since we're looking for kilograms, that the kilogram unit ends up on top. But what the heck does that mean? Well, you may have looked at this problem and said, hey, I just need to either multiply or divide 1,600 by 0.454. But which is it, multiply or divide? I'm going to teach you a system that has a very fancy name, dimensional analysis, but is actually incredibly easy and really a shortcut for kind of getting around problems that seem a little too hard at first. So all we have to work with in this case is the 1,600 pounds and our conversion factor. We're not going to worry about this 600 kilograms. That's not part of the conversion. It's a totally different thing. Now watch how I set this up. Pay close attention to those units. You always like to forget about the units when you're doing your math problems, but in this case, they're really important. I'm going to set it up so 0.454 kilograms over 1 pound comes first. Right now, our problems is, the way we have it written, we have 0.454 kilograms over 1 pound, when really we just want our answer to be in kilograms. So we need to get rid of this 1 pound somehow. If I multiply by 1,600 pounds, the pounds will then cancel, because as we know, a number is always the same as itself divided by 1, and because of how multiplication works with fractions, we can extend that fraction line and actually get 0.454 kilograms times 1,600 pounds divided by, and you can assume parentheses here, 1 pound times 1. And the reason why I set it up this way is, and this is the fun part, our pounds are going to cancel. Since our pounds cancel, the only unit we have left in this problem is the kilogram, and that's exactly what we're looking for. Now note that it's only the units that cancel, not the numbers themselves. It's like if you had xy over x. The x's cancel, and that's it. But if you had 3xy over, let's say, 2x, the x's would still cancel, but the numbers stay there, and so you'd get 3y over 2. So if we take away those units that canceled, we get 0.0454 kilograms times 1600 divided by 1 times 1, giving us our final answer of 726.4 kilograms. But what the heck were we even looking at again? Oh right, that was a conversion of 1600 pounds to kilograms. So now let's compare those two things. Oh, but wait, what if we had done it backwards? What if we hadn't multiplied but instead divided? This is why those units are so incredibly important. If we had divided instead of multiplying, our units would not have canceled. They would have instead become pounds squared, which is not a thing in this case. It would have been pounds squared divided by kilograms. We wanted it in kilograms, not whatever this thing is. So that's how we know we did it the right way. So now we can go back to our original problem and replace that 1,600 pounds with 726.4 kilograms. Now we can directly compare these two things. Because they're both in kilograms, we can compare the two numbers, and we find that 726.4 is obviously bigger than 600. So therefore, since one of the lightest cars, the 1960s Volkswagen, is bigger than a Blue Whale Heart, that thing you've been learning from the internet is actually wrong. Sorry, guys. So let's do another conversion. What's faster, a cheetah moving 90 miles per hour or a falcon moving 109 meters per second? We're also told that 1 mile is equivalent to 1,609.34 meters. Now you may know from elementary school that the cheetah is the fastest land animal, but how does that compare to the fastest bird, the peregrine falcon? And yeah, I know you're thinking that you could probably just put it into Google or some conversion app and see if 90 miles per hour is the same as 109 meters per second, but I'm teaching you a tool here that you can use in your math classes and you will definitely need in physics. So yeah, you're going to have to work it out by hand. So again, we're going to convert that 90 miles per hour, because mile is not metric, into meters per second, so we can compare to our 109 meters per second here. So in this case, we want to make sure meter is on top. We didn't have something on the bottom in our last problem, but in this problem we do. We have meters divided by seconds, so we need to make sure whatever we end up with has those same units. You can see I already put in that conversion factor they give us. 1 mile is equivalent to 1,609.34 meters. I knew to put the meters on top because I need meters on top to get us our final answer. Since these two things, when you divide them, are equivalent to 1, I could have flipped it the other way, but I wouldn't have gotten the right final answer. It would have been something divided by meters. So right now, just looking at the units in my problem, I have meters per mile, which is not what I want. I need to find a way to get that mile to go away. I know in this case that I'm converting 90 miles per hour, so I'm going to put that into my problem. Note that I can't just put 90 miles because it is attached to the 1 hour. So I have to put 90 miles divided by 1 hour. But that's okay. Our miles cancel. And now the units that I have as it stands right now are meters per hour, which is getting closer to meters per second, but isn't quite there yet. Fortunately, both the imperial and the metric system use the same time system. Even though most things in the metric system are based on a power of 10, the time is still just going to be 1 hour is 60 minutes. Which is great because now our hours cancel, giving us meters per minute. I can then put in one more conversion factor, minutes per second, and our minutes cancel, leaving us a final unit of meters per second. Hey, that's what we're looking for. So notice I didn't do this arbitrarily. I made sure whatever conversion factor I added was only added so that it would cancel out something from the unit, the conversion factor before it. And I kept doing this until I got the units I wanted, meters per second. Remember that when I said added, I don't mean that you're going to add these things. You're still going to multiply them all together. So once I get rid of everything that I've canceled, I end up with 1,609.34 meters times 90 times 1 times 1. And then that whole thing, and I always like to do it in parentheses just in case, that whole thing divided by 1 times 60 seconds. And then simplify, and you get your final answer of 40.2 meters per second. So look at that. The cheetah runs at 40.2 meters per second, while the peregrine falcon can fly at 109 meters per second.